Um, okay, I'm going to go ahead and get started. So thank you very much for coming out. I'm JD Lightsey. This is Building Privacy In. And because we're going to talk about the GDPR, and I work for a company, we have lawyers. They are generally not wanting people to talk about stuff like that. So everything I say is my view. I'm not a lawyer. Nothing I'm saying is legal advice. If you need legal advice, get a lawyer. And I'm not an expert in the GDPR, so assume that everything I say about it is incorrect, and you'll be safe. So, with all that said, why in the world should you actually be listening to me and listening to this talk? Well, my experiences for the last decade, a little over a decade, I've been working for cPanel, and it's a great company, a lot of fun. In 2013, at the very end of it, we actually introduced a security bounty program, and I was part of the team that set up around this to manage the bounty program and focus very squarely on the security of our product, the ways people attack it. And over the years, we fixed a whole lot of vulnerabilities. Right after the bounty program started, we had this huge spike of external reports, and kind of went down and bounced back up a little bit. And when you look at these totals, they don't actually reflect how many vulnerabilities the security team actually addresses, because we don't count things that we find before our product ships out to customers. And likewise, when we find vulnerabilities in other software that we repackage and ship, we don't count that as part of our totals. So it's actually quite a bit more than that. And of course, there are some things where we've just eliminated the possibility of that class of vulnerabilities by fixing the libraries, things like that. If you look at it, what we've been doing over time, right, it started where a large portion of the vulnerabilities were discovered by people outside of the company. And our security team, over time, we've gotten it to where the vast majority are things that we find, not people outside of the company. So we're around 90% at this point. Now, kind of comparing that to another sort of look at it is, how many of the issues do we find before we ship the software to customers? How many do we find after the software is shipped out to customers? That has come down also, but not quite as much. It's about 1/3 probably gets found before it ships out to customers. And that, for years, has kind of troubled me. And the thing that troubles me is, like, if we can find 90% of the vulnerabilities, why is it, the vast majority still end up reaching customers before we find them and fix them? And there are a lot of reasons for that. Over time, we've learned more about vulnerabilities. We have a lot of different priorities on our team. And also, like, the teams that are developing features have a pressure to ship. We tend to look at their stuff at the very end, so it ends up being that we're kind of blocking them from releasing, and that's uncomfortable for everybody. We have essentially different priorities than they have, and so you could almost imagine that they're working around us or something like that. But it's always important to assume that everybody is operating in good faith. They have the best interests of customers in their minds, and that's important to do. So. A while back, I really started thinking, what more can we be doing to actually help the teams writing the software to write really high-quality, secure software? And I had been doing talks for a long time, lessons learned talks. Whenever we would send out a security release, we would fix a bunch of vulnerabilities. I would go back and do a talk. Here's how the vulnerabilities functioned, exactly what an attack would look like. Here's the original mistake in the code that introduced this problem, so that teams could learn about how to avoid similar issues. Those are great, they definitely helped, but I figured there was more that we could do, like on a foundational level, how can we build very secure software? And so I did a series of 3 talks that were focused specifically on that, and really those talks essentially were about how to do threat modeling. That's the easiest way to approach this stuff. And I'm going to give a really short version of how to do threat modeling because it's foundational to actually talking about how to do privacy properly. So just by a show of hands, who has actually done threat modeling? Okay, yeah, perfect. So we have a few people that are familiar with it. Basically, the process is real simple. You start with a data flow diagram. A data flow diagram, if you've never heard of it before, it's because they're this old 70s concept from the structured design movement. But really, data flow diagrams are real simple. There are just four different elements that go into a data flow diagram. You have squares for external actors. These can be people or systems. Anything that's outside of the software system you're building is an external actor. The circles are processes, which it's not like a Unix process. It's more a data transformation process. You know, they are a data flow diagram, and so everything is an expression of what happens to data. The parallel lines are going to be data stores, wherever data is sitting at rest in some form, and data flows are just arrows. So to make data flow diagrams, you start with what's called a context diagram. Your entire system is represented as one process in the middle, and you're just sketching out all of the external interactions. And then you go down levels. So data flow diagram level 0, you're basically splitting out that single process into its major subsystems. And then we keep iterating down. Level 1, we can go into one of those subsystems and start splitting it out. And now we're starting to see data stores represented here. And we can keep iterating this way as deep as you need to go, 2, 3, 4, whatever. The real idea with the data flow diagram, and at least in that 70s view of structured programming, is that you're doing functional decomposition of your system so that eventually you get to the point where an individual developer can take one of those pieces and write it in isolation and have a sense of where it fits into the system. That's really the idea. For threat modeling, we're not so concerned about how to break down big problems into small problems. We're actually more concerned with the usefulness of a data flow diagram and showing how data moves through the system. Okay, so once we have a data flow diagram, we actually need to switch it up to be a threat model, which is slightly different than a data flow diagram. And really, a threat model is going to tend to be more specific about exactly the exact mechanisms that the data moves through. You know, like, is it going over an HTTPS connection? Is it JSON data? Is it XML? You want to actually be more specific about that. That may not really matter from a structure perspective, but it does matter from a threat perspective. There is one other element you add to a threat model that's not in a data flow diagram, and that's little dashed lines to show trust boundaries. You know, just where exactly are the rings that separate people, you know, or privileges. So like a real simple example, this is how one particular type of API request flows through our product. The simplest example is that the system all this stuff happens on is a trust boundary. Either somebody's outside the system on the internet or they're inside the system, you know, like on a command line. So that's a real simple trust boundary, but most systems actually have multiple levels of trust boundaries. So like in our design, the system itself is differentiating. You're either inside or outside, but on top of that, maybe the individual user can log in a shell. They're able to operate in that same ring as the UAPI call and whatnot. And then other things, maybe we have somebody with root access to the system who's operating in a malicious fashion. They would have a separate ring right there. And so looking at this threat model, we can immediately gain some insight into the system. Obviously, these trust boundaries are highlighting the major attack surfaces. These aren't the only ones. They're just the ones that are going to be most critical because they're right at the joining point between different levels of trust. We can also look at these trust boundaries and think, you know, what types of people are in these spots? You know, like somebody on the outside at that same ring as the browser. This is someone we may have no trust at all. The types of things they're going to want to do are going to be very different than somebody who, for instance, logs into a shell. They're running in the same ring of privileges as these parts of the system, or somebody that has root access and is operating in those rings. What types of things they're going to want to do, what types of things they're going to want to accomplish are going to be different. So once we have a threat model, though, then we have to do threat enumeration, right? And Now, what exactly a threat is not something that's kind of easy to understand automatically. If you look at these terms, threat and vulnerability and exploit is a very specific term. An exploit is like, I can send these parameters to this URL and it runs this particular shell command on the other side, right? Very concrete attack scenario is an exploit. A vulnerability is more a mistake in the code, a mistake in the design that made it possible to do the exploit. So where the exploit is, I can run this shell command by sending these parameters. A vulnerability is going to be that you didn't validate the input parameters, or that you didn't escape it when you used it in a shell command after the fact. Threats are still going to be even more general than a vulnerability. A threat is more of a risk. So without looking at the code, we can say that when you're doing this type of thing, there's a likelihood that you will make this type of mistake. And that will in turn become a vulnerability. The vulnerability in turn will be used in an exploit. It's generally the idea. A lot of the stuff I've read, though, says that risks are a different thing than threats, you know. But it's easier in my mind to sort of think of them as risks of vulnerabilities. So for actually doing threat modeling, there are two ways you can go about it, or in my mind, two ways. We can either use canned threat lists or manual threat enumeration. For canned threat lists, there are, like, they call them attack trees, big lists of them. You can go through and look at which ones apply to you. I have a demo of one form, though, of canned threat lists. Let me switch this. Let's see if this works. Hey, there we go. Okay. So I don't need LibreOffice. Okay, so this is a Windows VM running on my machine, and I'm going to show you what's called Microsoft's threat modeling tool. I generally don't use a lot of Microsoft software, but at the same time, this is without a doubt the best zero-cost threat modeling tool you're going to be able to get out there. It's not free software, but it is free in terms of price. And this particular threat model, I'm sorry if this is probably going to be a little hard to see. This particular threat model, we've used this at different Houston Perlmongers meetings to kind of practice threat modeling. The idea here is this is kind of sketching out how we would implement something WordPress-ish in Perl, how it would be organized in a general sense. And the nice thing about Microsoft's tool is it actually makes drawing these diagrams really easy. A lot of other tools are slightly more complicated if you want to do it in a software tool. If you're just doing it with other people, like doing threat modeling, it's easier to go to a whiteboard and just draw it out. But one nice thing about this tool is as soon as we've plugged in all this stuff and drawn our trust boundaries, it actually starts generating threats. It sees that, well, you use this type of element on this side and this type of element over here, and it has a bunch of programmatic logic to say that sort of relationship between these things implies this threat. And so it has a bunch of them that it just lists out automatically. In fact, like this tool is totally focused on this automatic threat generation. It's actually not very good as when you try to enter them manually. And it also has a bunch of stuff for tracking it. So you can put them in, like they're actively being worked on, they're not appropriate for this reason or whatever. I think Microsoft actually uses this very prominently in their development process. And it can generate these nice reports with the overall design and lists out each and every threat and describes it, what its current status is, yada, yada, yada. So if you want something automated, that's a really good one. Let's see if this... Nope, back at slide 1. Let's see. Hey, okay, all right. So what's that? That's essentially a what a canned threat list looks like, and that's a great place to start. Super easy. This is probably why Microsoft uses it. You don't really have to explain to people how it works. They just plug in their stuff and they get a list, right? But it's never going to be very complete because it is a canned list of things. So if you want to do it by manually, we just want to sit there and figure out what are the threats for our threat model. Then we basically need to step through each and every element that we've drawn out, each data flow, each actor, each process, each data store, and we say, who can interact with this? How are they going to interact with it in some way that the designer might not expect, and what are they going to gain from that interaction? If you can answer all that, then you've got a threat. You keep doing that until you run out on that element, and then you keep walking across the other elements. Easy peasy, right? Well, most people, when you actually sit down and you're like, come up with the threats on this thing, they have trouble coming up with threats on it. So there are taxonomies of threats. The common one that people talk about is STRIDE. It's pretty simple. Spoofing identity, tampering with data, repudiation, meaning denying that you did something, which almost always you fix with logging. Information disclosure, denial of service, elevation of privilege, the different categories of threats. These aren't threats in and of themselves, they're buckets that you would define threats within. And the STRIDE taxonomy also tends to associate with certain elements in the threat model. So when you're looking at the actor, you can really focus on the spoofing threats and the repudiation threats. And so it kind of guides your thinking. STRIDE, though, and all this stuff is not about, like, this is the right way to do it. It's about, this is a way of sort of bootstrapping your thoughts. Because threat modeling is essentially brainstorming. And so you need people to spit out their ideas. You don't reject anything. You write them all down. And then at the very end of it, you go through and rank the threats you found and decide which of them are you going to mitigate by adding more code to the system that specifically addresses that threat. Is it something that we don't really need to fix, but we just need to keep in mind as we're developing it, for review, for testing, for documentation? That's generally what you do with it. And since nobody does these big waterfall processes where we spend weeks planning things ahead of time, nobody takes that approach anymore. You basically come up with your first design, and each sprint you go back, you say, have we changed the design in a way that we need to go back and update the threat model? Did we add new elements? Then we can go and enumerate threats on those particular elements. So that's the short version of threat modeling. The long version is 3 hours. So I'll skip over that. But because really y'all wanted to see a talk on the GDPR and privacy, right? And so oddly enough, when I was going through and doing these talks on how to do threat modeling, this was the same time frame where cPanel's lawyer was going around and asking about what we were doing to build secure software. And while I love talking about what we do to build secure software, he was actually asking because he was looking at how do we document our compliance with Article 32 of the GDPR. And this is the legalese version. Kind of simplified, Article 32 says that you have to actually do something proactive to build secure software to make sure that your company's operations are secure. And you can demonstrate that one of two ways. Either you use industry standard practices, or you get a certification saying that you did all the needful. And of course, once you comply, it doesn't mean anything. Don't expect the compliance counts. But if you don't comply, that probably will hurt you. So, I would imagine most companies, they look at that and they're immediately like, I can get certified. I'm already certified for all kinds of junk. And so they just immediately jump on certification as the route that they want to go to demonstrate that they're meeting Article 32. What was really cool, though, is that our lawyer was not looking at it from that perspective. He really wasn't as focused on documenting certification, but he wanted to look at what we were actually doing to build secure software. So that was awesome. And when we sent out our GDPR announcements, at the very end of them, there's a Schedule 2. It talks about everything the operations team is doing to make sure their operations are secure. And below this, it actually talks about what we do in terms of product security. And this kind of one thing that jumps out of this is why, if the GDPR is a privacy regulation, is it talking about security, development security, operations security, and so on? But really, if you think about it, it makes total sense. You can't really build a system that's going to respect and take care of its users' privacy if it's not a secure system to begin with. It's a prerequisite to building a privacy-respecting system. Now, when cPanel was setting up everything and rolling out all our GDPR changes, our lawyer did a talk on it, and there were some other really interesting tidbits in what he talked about. Like the GDPR, it starts with Article 4. It has a bunch of definitions for things that we just all assume we know what they mean. And then it has a bunch of sections on the principles of processing data in a way that respects your user's privacy. It talks a lot about consent. What does it mean when you get consent? What are the things you can do without asking for consent? So you don't have to pop the box in front of every single website, you know? It would be nice to not do that. But it also has a lot of sections talking about the rights individuals have over their own data and what they can basically ask you to do with the data that you've collected on them. And a lot of what's in the GDPR, it's actually not that dense of a document, even though it is a legal thing. A lot of it makes sense. There are some things that obviously don't make sense. Article 17 is the GDPR's version of the right to be forgotten. That's always been kind of tricky, the idea that you can ask a company to delete all of their data on you, because it just doesn't reflect the reality that that's not how most systems work. Once your data is on the server, it ends up in backups. You know, like actually going through the backups and deleting data selectively makes no sense. The GDPR doesn't really fill in those details particularly well either. I guess courts will figure out eventually. One part, though, that I was really interested in as soon as I read about it is Article 25, data protection by design and by default. And this is the long legalese version. The short version is that basically when you're building software, when you're setting up your operations, you have to factor in the privacy concerns of your users into these systems. And you should set up your defaults with an aim towards maximizing their privacy. And for this one, it's not an either-or toggle like the other one. Instead, you can get certified, but that doesn't mean that you're not supposed to be actually doing these affirmative processes. And when our counsel was talking about it, it was pretty. Nobody really knows exactly what that means. How do you factor in privacy while you're actually building the software? That's not a well understood concept. And so he was saying that he wasn't really sure how to do that. I immediately contacted him afterwards because I'm like, hey, I know this one. While I was learning as much as I could about threat modeling, there is something quite similar, where you're trying to build software that respects privacy. There is a thing called privacy threat modeling. Essentially the same concept as security threat modeling, just looking at different aspects and from a slightly different way. Because really, if you think about it, when you're doing security threat modeling, you're already documenting what data you have, where it's flowing, where it's sitting at rest, who has access to it. This is the lion's share of the stuff that privacy is concerned with, the data and where it is and how it's being used. Really, for privacy threat modeling, all we're missing is a way of enumerating privacy threats. And just like we have Stride for security threats, a framework for structuring your thinking, there are other frameworks that focus specifically on privacy. The one that probably is the most well-developed is called Linden. And because it's focused on privacy threats aren't exactly the same as security threats. Say in a security threat, you have an attacker, you have a victim, you have the thing they're doing, right? In privacy, really the subject is the main thing, the user who has some private information. They're the one that loses everything. They're the one that suffers. Nobody really attacks them directly. They just end up suffering as a result of mishandling of their data. Now, the subject has items of interest, essentially discrete parts of private data. Say, like, my social security number is one item of interest, my mailing address is another, my email address another. Which of them actually forms my identity? You know, who can really say? But they're all just discrete, personally identifiable data. And where in security threats, we talk about mitigating them with essentially adding new functionality to the software. When it comes to privacy threats, you can mitigate them to a certain extent with what's called privacy-enhancing technology. It could be encryption, hashing, anonymization, all sorts of different things, depending on the particular threat. So to go into Linden a little more, though, it's not quite as snappy of a name as Stride is, but a lot of the stuff is pretty straightforward. So we have linkability. Like, if you take, say, my mailing address and my social security number, if you can tie those two together, even without understanding who I am, that's a linkability privacy threat. And kind of a more extreme version is the identifiability. If through one or multiple items of interest you can figure out who I actually am, then that's an identifiability threat. Linden has non-repudiation as a threat. Essentially, if I can't deny that I used your website or whatever, that's going to be a threat to my privacy because you kept logs or tracked who I was or whatever. Detectability, this is really like about being able to tell that the data exists, even if you can't actually tell the details of the data. Information disclosure comes straight out of Stride. They include it in Linden, even though it duplicates Stride because you don't have to use them together. You could be looking at them separately. Content unawareness, this is basically that whatever data the system is collecting, that you are aware the data exists within the system. If you're not aware, then that's a threat to you, the subject, because it is there and you're just not being told about it. And likewise, once you are told, there's policy and consent non-compliance, probably the worst one out of this naming scheme. But basically, this is talking about that once you've made agreements about which data is going to be there, how it's going to be handled, the software needs to behave in accordance with those agreements. That's the idea. So, like with Stride, these things tend to map to certain elements. And the process of actually using it is pretty much identical. You iterate across the model. You think through, which items of interest are at risk here. How could they be misused? Who could be doing it? And so on. And so you write all these things down. You rank them in terms of importance. And basically, you can approach these problems in a variety of ways. The easiest is to do data minimization. Basically, if it's dangerous for us to have this data, if it doesn't really serve a solid purpose in our system, don't collect it. That's the easiest approach. If you really do need to collect it, you can use privacy-enhancing technologies. Say, like a simple example, if we're sending data to an offsite system, if we're SSL of that transport is a privacy-enhancing technology. And maybe it goes much beyond that. You want better anonymity or whatever, depending on what you're building. Obviously, you can write down all the data that you're pulling in so that you can gain consent, and of course you can validate that your system actually complies with the policies you already have. So if you're building something like Tor, where you want a perfect privacy system, Linden is excellent. You go through every last bullet and check them off without doubt. But most of us don't build those systems. We are building sites where things are bought and sold, where people post their cat pics so their friends can see them, stuff like that. And so a lot of Linden doesn't actually make sense in what we're doing. These four, though, on the ends, the linkability, identifiability, content awareness, and policy and consent compliance. Essentially, these are the very things that GDPR is talking about. That if you're making any sort of representations about the anonymity or pseudonymity of your users, that you have certain obligations to actually meet that. And likewise, regardless, whatever you're collecting, they need to be able to know about it, and you need to actually stick with the terms that you're putting in front of your users. So those are pretty simple and pretty universal. Information disclosure, it comes straight out of Stride, so you should be doing that regardless. Detectability, really, if you think about this, this is a more extreme view of information disclosure, that anything that's personally identifiable, even being able to tell that it's there, is a bad trait of the software. But it's going to be debatable how much that actually matters in your system. The one that really stands out is non-repudiation. So if you remember, in Stride, repudiation is a category of threats against the security of the system. And you add a bunch of logging to make sure that people can't deny they did something. And in Linden, non-repudiation is the threat against their privacy. The fact that you logged it means they can't deny that they did it. Obviously, these are directly in opposition to each other, the privacy of the user and the security of the system, as expressed by these frameworks. And the reality is, this is all just a balancing act. These are trade-offs that you make, and there's no right or wrong answer as to which trade-offs are more important. It depends on the system you're building and the things you're telling the users of that system. In fact, even beyond security and privacy, even beyond the security and privacy of the system, the functionality, the speed of delivery, reliability, these are other things that have to factor in. They're all trade-offs that go into it. And really, these frameworks are designed to make you aware that you're making the trade-offs, more so than to say this is the right approach for it. Ultimately, no matter what you do, you can always document that it does the thing it does, and that makes it okay. And that's true for security, privacy, usability, reliability. It doesn't matter that it crashes 3 times a day. If it says in the documentations, we expect it to crash 3 times a day, it's working as designed. Yeah, I think though, realistically, we should all be aiming higher than just loading up a bunch of disclaimers in our products. It's kind of a bad sign when that's what we have to do, because really we use this stuff too, and we should be able to expect more. I don't want to have to click through 5 pages of legalese every time I use stuff, and so it doesn't give me any satisfaction to expect that I can avoid doing the needful, so that route, Now I probably don't have time. I'm not sure. Let's see, 12:04. I wasn't really expecting to have a bunch of time to go through specific examples. One thing I would say is that you won't find a whole lot of documentation on how to use Linden in a practical sense. You will find a whole lot of documentation, YouTube videos, and what have you, that talks about how to do security threat modeling. And so it's probably a good idea to focus on that first, and then once you feel like you've become comfortable with threat modeling for security issues, then look at the privacy issues, because they're going to be a little harder to reason through because you won't be able to find as many examples. For instance, like when any piece of software, when they find a vulnerability and they fix it, they announce it, right? When they find a privacy issue and they fix it, they're probably not going to announce that. It generally just doesn't get announced because it's not the software and the operations folks doing that. It's generally legal that gets involved in those sorts of things. And they don't like to make big splashy announcements about stuff. So aside from that, like one footnote item, we had automated generation of threat lists for security issues. Why don't we have that for privacy issues? No particularly good reason. I can't think of any good reason for that. That Microsoft tool, you can actually design your own threat list using whatever naming scheme you want to use. It doesn't have to use Stride. And in fact, you can take a given threat model that you've plotted out and switch the threat list that it's actually using. It's in the tool, you basically apply a different template to it, and it generates a different list of threats for you. So it would be entirely possible to have that tool spit out a bunch of Linden threats automatically. As far as I know, nobody has actually written the templates to have it do that, although it would be nice if somebody did. Footnote number 2. This book right here, Adam Shostak wrote this book. He has a lot of good talks on YouTube. This is an excellent book. This is what actually made me aware of the Linden stuff, because he has a chapter specifically about how to do privacy modeling, although the majority of the book is about security threat modeling. One other thing. So the GDPR, where it's talking about building privacy in, it actually uses these terms, right? These terms, in a legal sense, may mean something very different than the concept of building in privacy by design or privacy by default. There is an older sort of a collection of guidelines that was put together in Canada by somebody in the Canadian government, and this is called privacy by design. And the Linden website actually has this text in their tutorial, which says that Linden follows the privacy by design principle, but it may not meet privacy by design from a legal perspective. I think, and I'm not certain about this, but I think privacy by design is a legal term and like a certification in some contexts. Everything I've read about the GDPR is that wasn't the intent of their usage of these terms. But I don't know. I'm not a lawyer, you know, and admittedly I'm not an expert on the GDPR, and I'm probably lying to you anyway. So don't trust me, just something to be aware of, you know, especially if you want to go this route. So that's basically all the material I got. Any questions, anything? Yes? It kind of depends though, because say even in standard weblogs, they have IP addresses. Most people consider IP addresses to be personally identifiable information, so they're definitely in competition to a certain degree. If I'm setting up, say, a Tor exit node, the thing I'm not supposed to be doing is logging which requests were going out, who was sending them, and whatnot, you know. And if I do that, essentially I am creating a non-repudiation flaw. Same with an entry node if I'm logging which IP addresses were connecting to me. I don't know. It's a fuzzy area, and it really depends on the goal of what you're actually building. It is a worthwhile thing to think through, though. You know, like, is what we're logging appropriate for the level of it? The GDPR has a lot of stuff about basically transforming data into anonymous data as opposed to personally identifiable data, and that kind of puts it outside the scope of the GDPR. So things like web logs, as long as you don't need it for that repudiation purpose, then you just want stats or something like that. You would go ahead and anonymize it. Yeah. Any other comments, questions, anything? Oh, thanks. Yeah, when I did this at cPanel, and we were looking specifically at security threat modeling, we actually spent a lot of time going over the specific mechanics. This particular book right here, so Adam Shostak, in addition to this book, he worked for Microsoft, and a lot of this stuff was put together while he was working for them. He has a card game that he put together also, where you basically take your threat model and you play a game. It's a lot like Spades, if you've ever played Spades. And everybody gets a card, and so you follow the same suit, and the suit is one of the stride categories. Somebody plays, a spoofing threat, and they say where on the threat model it goes, and they describe how it kind of goes there, and you go around the table, and everybody does that. And it's a great way to get people sort of thinking about how to enunciate these things, without just staring at everybody else. We actually did that at one of the Perlmutter stocks. Yeah.
Well, I'm wondering if you ever got to the point where you approached your programmers and you said, "Here, guys, if you find you're passing some information that they don't need over there where you're passing it, I want you to conscientiously take it out. Like they're passing an object, for instance, right?
Yeah.
Don't include that SSI with that object. Have you gotten to the point where you do that?
Well,
Or is it still, do you keep it at this high level?
well, no. Like I was saying, all along since we formed our security team, we go back and do, a lessons learned talk after each security release. So those low-level sorts of things of here's a specific way this can be done wrong. We do talks on those very things. And where the issue comes up repetitively, those tend to be more the focus of those talks because it's more actionable by individual developers. But the problem is, like, say building reliable software is not just a matter of removing bugs from software. There's a difference, in what you're doing there. And so, like, the goal of promoting threat modeling was to get people to build software that is secure from the get-go, not that we fix it by removing vulns, concrete examples of. I really wouldn't want to talk about that because I mean honestly, a lot of the thing is like the company's efforts in that regard are I'm not like our data protection officer or anything like that, and I'm not in charge of those things, so I wouldn't want to talk about anything internal of the company in that respect. Like I mean. Know a lot more about the security of the product and the efforts at GDPR compliance, privacy compliance, and whatnot. Like the overall framework was something I was wanting to promote. Any other questions or comments? No. Okay. Well, thanks.